All right, in this video, we're going to talk about a few other ways to investigate limits. The first one is called the sandwich or squeeze theorem. You hear me refer to them as both, but sandwich, squeeze theorem, all the same thing. And so we'll start off with a picture, and then I have the picture then represented in words. We're letting g of x be less than equal f of x less than equal h of x for all x in the neighborhood or in the vicinity of our x equals c. So that just really says that function g is on or below function f, which is on or below function h. And so essentially f is always bounded between h and g. So we can say that since the limit, and you can see this from the picture, as x approaches c of g of x equals L, which is also the limit as x approaches c of h of x. Right, the h of x function, the black curve, has a limit of L. The g of x, the blue curve, has a limit of L. Since those are the same and f is always in between them, then the limit as x approaches c of f of x also has to equal L. Okay, so let me show you an example of where we might use something like this. So limit as x approaches 0 of x squared times sine of 1 over x squared. So in this particular case, you can see very quickly that by taking the 0 and plugging it in, you're not going to get anywhere. But because sine is a very, very special function, we can take advantage of this squeeze theorem. We know that sine of anything is always bounded between -1 and 1. We know that, right? We've seen the graph of sine. It's always between -1 and 1 unless there's some other part to the function. So now, since that's the case, and I have this inequality, if I multiply all parts of the inequality, all parts, by this x squared, I'm going to have a negative x squared less than equal x squared sine of 1 over x squared less than equal x squared. Now I've got my function that I'm interested in studying there in the middle. So off to the side, if I look at the limit here as x goes to 0 of negative x squared, and here the limit as x goes to 0 of positive x squared, I can see that both of those would be 0. Therefore, the 3 dots in a triangle like that means therefore the limit as x goes to 0 of the inside part, remember it's bounded on the bottom by this and the top by this, therefore the inside one has to also be the same. So x squared sine 1 over x squared also has to equal 0. And that's by the squeeze theorem. So if we're able to set up an inequality like I have and find out that what's on the top end and the low end are all the same, what's in the middle also has to be the same. So a pretty useful tool for a lot of functions such as sine and cosine. All right, so the last method that we're going to talk about in this section is going to be a numerical approximation. This is definitely not one that we go to a lot because it's very tedious, but it does demonstrate that we understand truly what a limit is doing, and it is very effective. It will work. And so if we take our x and plug it in to everything in the function, you can see we get our 0 over 0, which is an indeterminate form. And so I'm going to rely on the numerical approximation technique here, even though it might not be the most efficient. So what I'm going to do is I'm going to actually set up a table, x and f of x. And remember how we talked about we want to approach 0 from both directions? So what I'll do is I'll select numbers like 0.5, negative 0.5, negative 0.05, negative 0.005. And then on the other side, I'll do the same numbers but positive. And so you can see we're approaching now 0. 0 is going to be somewhere here in the middle. I'm approaching it from the left. I'm also approaching it from the right. So I'm taking numbers really, really close to it from both directions. So now I'll take these numbers, these x values, and I'll plug them in up here. Now, I haven't mentioned it yet in this course, but calculus only works in radians. It does not work in degrees. So we need to make sure the calculator is in radian mode before we plug these numbers in. So when we take our calculator, we make sure it's in radian mode, we plug it in, we get numbers like these. And these numbers are just going to be approximations. I think it'll be very clear once I get them up here what the answer is, but again, to save some time, I'm just going to put these numbers up here. So negative 0.4896, negative 0.4998, negative 0.4999. And then this function, actually, to save a little bit of time, if you catch it, it's an even function. If you run the even and odd test on it, you'll find out that it's an even function, in which case the negative answers will be the same as the positive answers. So this would be negative 0.499, negative 0.4998, and negative 0.4896. So as we approach zero from both directions, you can see where we're headed, right? It looks like the answer here to this would be a negative 1/2. So as we approach zero from both directions, the y value output would be that negative 1/2. So again, it works great, but it's not very efficient, and so we don't use it very often, but it is a tool that you can certainly apply given certain limits, and one that hopefully gives you a better understanding of what it is you're actually finding.